Okay, good morning and welcome to the second half of our angles and parallel lines and transversals lesson. If you are in my class, we are in the new note packet. We're going to start on example 3 that looks like this. So that would be the back of the second page of the note packet. Okay, so here's what we've got today. So yesterday we learned that we could make a pattern with the angles on a set of parallel lines that are cut by a transversal. So the first thing when you see a figure like this that you have to keep in mind is that there is a pattern. So it will help if you can color code your diagram. So pick a color. I'm going to pick red, and I'm going to make this angle here red. And I'm going to make the next angle blue in a second, but I know every other angle is going to be red. So red, not red, red, not red, red, not red, and then red. Okay, so every other angle for me is red. I'm going to pick blue for the other angles. So this guy is going to be blue, red, blue, red, blue, red, blue. So it should make a pattern of every other one. The reason we do this is because then we can see which ones are equivalent. So all the ones marked in red are equal to each other. All the ones marked in blue are equal to each other, but they'll be different. Now, notice that this one marked in blue says it's 60 degrees. And then over here, this one says it's 2x plus 10. Since they're both marked in blue, we know they're equal. So what we're going to do is we're going to write it as an equation that we need to solve. So we're going to write it as 2x plus 10. We know that is equal to 60 degrees, like that. And what it's going to end up giving us is a two-step equation to solve. So going back to the very beginning of this year, we know that to get x by itself, we need to undo everything that's on the same side of the equation. So 60 is all safe already, so we don't have to undo that. The first thing we'll undo is plus 10, so we're going to subtract 10 here and cancel it, and subtract 10 from the 60. So bring down 2x. 60 minus 10 now is 50. And then to undo this 2, this really means 2 times x, so we'll divide by 2 here, and divide by 2 here, and find out that x equal 25 degrees. And that's how we solve then for x on a situation like this. Okay, now let's do another one that's similar to the one above. So in example 4, it says in the figure below, A is parallel to B. What's the value of x? So again, we want to start out until we get good at it by doing the patterns again. So I'm going to start with my red. So red, not red, red, not red, red, not red, okay, and then red, not red. And so for me, I'm going to make the not red ones again blue. So 4 is going to be blue, 1 is going to be blue, 3 will be blue, and my x plus 12 here will be blue, okay? And so now this time, we see that the two things that I need, the x plus 12 and the 59 degrees, are not the same angle, okay? And so solving for x, we can't just set it equal to 59 because this is my blue angle and that's obtuse. And you can see that my red angle is acute. Now, I can figure out what the blue angle is going to equal by subtracting from 180, because notice that the transversal provides a straight line here. So if this much of the transversal is 59 degrees, what's left over, we know that the whole straight line is 180 degrees, then I would subtract 59 degrees, and I would figure out that, this is going to give me 121 degrees. So my blue angles are all 121 degrees. Okay, so now I can set up an equation. My blue angle over here to solve for x, it's saying x plus 12. Now I know that's going to equal 121. Okay, don't forget that there is a hidden 1 in front of that x, and now I can solve this, okay? And so the first thing I want to do is undo that plus 12, so I'm going to subtract 12 here, because that's the opposite. Okay, bring down 1x, and then 121 minus 12 is going to give me 109. Okay, and then I divide out that 1 because that means multiply. Well, dividing by 1 gives me the same thing. Oops, I'm sorry. So I get x equal 109 degrees. And that's how I solve it. Okay, that's it for notes today. We're going to do a practice on all of what we learned with the degrees yesterday and today.